Okay, so in the previous lesson, we discussed what exactly is a RAG. And during that discussion, we came across three different ways in which a retriever function can work, right? Let's try to see what those three different ways are. First is web search. Second is database query. And finally, we have vector database query. I'll call this as structured database query just to keep it separate. So web search is pretty simple and basic actually. So let's assume that you have a SERP API, which is an API that is built for doing a web search, Google Search API. It's also it is using the Google search engine. That is why we call it SERP API. Or let's take Brave Search API. This is using the Brave search engine, so you can expect some really good results from this as well. So these are all different APIs that you can use. So which means your retriever function, this guy, your retriever function has to write a search query, whatever we will usually put in Google, right? Here I've put LNTCO. Similarly, your retriever function has to write this query and it has to use the API to get the web results. That is for web search. API, Brave API, Bing search. These are some of the different APIs that are available to do web search. Now coming to structured database query, here it's slightly different because now you're writing query not for doing web search, but let's keep it slant, it's nice. Yeah, so here you're writing your query not to do any web search, but rather you're searching for something inside of a database. So let's say you have some 10 different tables, or you have two different databases and each of them has 10 different columns. Now you have to identify which database has relevant content, which tables have relevant content, what columns do you have to use, and you need to write the SQL query. So this SQL query, it can be MySQL, it can be PostgreSQL, it can be some other thing as well. But at the end of the day, it is going to be a SQL query. You will write this SQL query and you will execute it on your structured database. And then you will get the results that is going to become your relevant content, this one. And the third way is vector database, which is what we are going to study today. So vector database, I think I've already explained what exactly is a vector, what is an embedding previously. Where did I explain? Yeah, here. So every token is converted into an embedding, which looks like this. We can call it as a vector or an embedding, same thing. Slight difference is vector is just a numeric representation, but whereas an embedding has a semantic meaning also. So all these numbers, they are created when you capture the semantic meaning. In that case, it is called as an embedding. But if you're converting just text into numbers, they are basic vectors. Okay, so in a vector database, if you plot similar vectors together, where is my king? Okay, sorry. Yeah, if you plot all the similar vectors together in a three-dimensional plane, this is what you're going to get. All the similar stuff will be in one place, and the distance between irrelevant things or dissimilar things is going to be much more far. Mobile, laptop, both are electronic devices, so they'll be in one cluster, in one area. Illusion, magic, hallucination, all these different mind-related things, they'll be in one cluster, in one area, in one group, and all the proper nouns like king, woman, hostess, queen, woman, man, all these different pronouns. Yeah, they are pronouns. Yeah. So all these different pronouns, they will be in one proper cluster in a totally different area. Now what we can do is we'll build this vector database, and then instead of using just single words, we are going to build it with chunks, or I should say sentences. So instead of single word, these are going to be different sentences. Okay, let's come all the way back. Yeah. So sentences are stored in a vector DB. Now, how are they stored? I'll take the sentence, I'll convert that into embedding, or let's just say vector. From vector to embedding, and or you know what? I'll remove this embedding. Let's use the word vector for now. So sentence will be in alphabets. Those will be converted into numbers in a vector format, and then we will push to vector database. So these are the three different steps that we usually do in vector database querying. Once you push it to your database, then you will simply query. Querying is also an art. You need to learn how to query a vector database also. We're going to explore that as well in the upcoming lesson. But let's try to build this part in Python. Let's try to see how can we create a vector database, how can we convert these sentences into vectors, and how can we push them into database, how can we do the querying also. So before we do all of this, let's focus only on this part first. So let's create a vector without any semantic meaning. It's not an embedding, okay? It's a very simple vector, just some array of numbers. Then we'll push it into a vector database and then we'll query it. To do this, there are many different tools actually. Uh, we have two of the most popular ones are Chroma DB and Index. These are two of the most popular ones. We also have Azure AI Search, which I love to use. And there are many others also. We also have Vector Store from OpenAI. This is directly from OpenAI, and this is what they're using in the ChatGPT backend. So you can imagine how powerful this can be, but it is such a hassle to set it up. That is the reason why I always prefer Azure AI Search. But yeah, these are all the some of the most popular ones that we can use. Apart from these, there's also Pinecone, which is also quite popular. We're going to take a look at all of these different items as we go forward in this particular lesson, in the same lesson. But for now, let's go ahead and implement this first part using Index. Okay, so we are back in our repository. Let's try to create a new Jupyter notebook. Fag test. Okay. I hope you guys have already seen this example, which shows how an embedding actually looks like. But just to be safe, I'll run it for you. It's very simple. It's using transformers library and it's using, where is this? Yeah, this particular model, all mini LML6 V2 model from Hugging Face sentence transformers. I can also use the sentence transformers direct library, but for now, I'm just going with transformers, which is Hugging Face library. So from auto tokenizer, I'm importing this module and I'm creating a object of this encoder and I'm tokenizing these two sentences. Okay. I'm taking this one. This is an example sentence. This is one string. I'm converting this sentence into a vector representation. An embedding, it is numbers basically. All this text will be converted into numbers. Uh, Same thing goes for this as well. But try not to get confused between these three terms. Okay. We have tokens, we have vectors, and we have embeddings. So these three are some of the terms which will definitely confuse many people. Also, you will get this question asked many times during interviews. You will create tokens. From tokens, you'll create vectors. From vectors, you'll create embeddings. These embeddings will be stored in vector database. And even for model training also, you will use these embeddings, not the vectors, not the tokens. How are the tokens created? From the sentence, you are getting your tokens. How are sentence getting created? From paragraphs. But the thing that you have to understand is we don't call them paragraphs and sentences. We call them documents and chunks. So from document, you'll get your chunks, or actually let me put them in bracket. Okay. So from documents, you'll get your chunks, and from chunks, you're going to get your tokens. From tokens, you'll get your vectors. Vectors will be converted into embeddings. So you need to understand the difference between all these. Okay. Environment has been loaded. So let's try to convert them into embeddings and let's see how embeddings actually look like. No more to transformers, seriously. Yeah. So this is how an embedding actually looks like. If you go into actual output, you can see the first sentence embedding is this one. This is the second sentence. And you can see these are all just numbers, but extremely small numbers. You can see this is in exponential format. So it's even more smaller. Okay. So this is how we will represent a sentence in embedding format. Let's try to create faz index. I believe I should have the code here itself. Yeah. So this is a very simple piece of code where we are creating some vectors using NumPy, and then we are storing it into that index, and then we are querying. Let's copy this. I'll paste it here. Instead of running all of them at once, let's import everything. Now, if you see, dimensions is 128. Number of vectors, I'm taking 100 different vectors. I'm using numpy.random to create all those different vectors. Let's see how they look like. So they'll look like this. There are 100 items in it, and each item has 128 values inside of it. Okay, 100 items, and inside of each item, you have 128. Next, let's create the index, and we are going to pass the number of dimensions while creating that index. Now the index has been created and it is stored inside of this index variable. Now I'm going to take all those vectors, I'll add it to this index. Now this is very simple. What we did here essentially is, let me copy the diagram and put it here. So what we did was, it was previously empty like this, but we added vectors. Now it will look like this, but instead of words, we have these vectors. Yeah, we have inserted all of these into our index. Now we are going to query it. To query I'm going to create one more query vector. Let's see how it looks like. So this is also one more vector. Okay, it's very, very simple. Then it looks pretty much the same if you see, and the size is also going to be very similar. 128, right? Because I'm using the same dimension. Okay, so I'll take this query vector. Now it is going to do a search in the index and it will fetch the relevant queries. What exactly is this search? How is this able to search? There are two different ways in which we can do that. Semantic search, cosine similarity. These are the two different techniques, most commonly used techniques, using which we will compare two different vectors. So what will happen is I'll have my vector 1, vector 2, vector 3, vector 4. Let's assume there are only four vectors in my index, and this is my query vector. For every single one of the vector in the database, I will calculate their similarity score. So I'll use cosine similarity or semantic search to assign a score. Let's say this is 98% similar. This is only 19% similar. This is around 20% similar. And this is 86% similar. Or let's shuffle them. Okay. So these two are similar by 98%. These two are similar by 20%. These two are similar by 86 and these two are similar by 19%. Now let's say my top n or top k is equal to 3, which means it will take the three topmost results, which is this, and this is the second topmost, and this is the third topmost. So it will take all these top three matching results, and it will return the input vectors. Sorry, it will return the actual vectors which are present in the database. So here we are giving the k as 5, which is top n or top k. It is also giving me the distance. So let's try to see how near all these queries are. Okay, so uh, these are the indices in which we have our vectors, which means in the sixth index, we have a vector which is very similar to this one. Let's try to see that. My vectors. So it is saying that this sixth index, which is this one, this array, this vector is very, very similar to my query vector. Obviously, as humans, we have absolutely no idea if that is true or not. First of all, there's no meaning in all these vectors because they're created at random. But if you do the math, then apparently this is the closest match that it is able to find. These are random vectors, so we cannot expect much. But if you want to try it out with a much more glorified way, you can create these vectors using this transformer model, and then you can try it out by yourself. You can put it in your faz index. You can create a index with the respective dimensions, and then you can insert all of your vectors, and then you can do the searching. We are going to do something similar to that using ChromaDB. The only difference is ChromaDB by default, it will use this model. I don't have to create the embeddings separately. It will use this model by default, and then it will create those embeddings all by itself. If you are running ChromaDB for the very first time, then it will install a few things. And over there, you can see the actual model that it is downloading. It will be somewhere about 200 MB. It will download in the Jupyter Notebook itself. First thing is you need to install ChromaDB. I'm pretty sure I already have it installed. Second step is import ChromaDB, and then you'll create a persistent client. This is very important, guys. Persistent client is different from normal client. Yeah, requirement already satisfied. Okay. Okay, persistent client, and I'm giving the path as ChromaDB, chroma underscore data. So persistent client will create a folder with this name, and it will store everything in that folder. If you don't create a client, you can just simply pass it like this also. ChromaDB.client. This will also work, but the problem is your database is now stored inside of this variable, which means if I close this Jupyter notebook, if I reopen it again, I have everything lost. Everything is lost. So whatever embeddings I've created is gone. Whatever collection I've created is gone. I'll have to start fresh again. So this is why you need to create a persistent client, and it will create a folder here. You can see, yeah, chroma underscore data. Instead of that, you'll have a SQLite database. Instead of the SQLite database, it will store all of your embeddings. Okay, we have created our client. Now let's add a collection. You can think of collection like a table. I'll say rag collection. This is the name that I'm giving. It will get it if it already exists, or it will create it if it doesn't exist. So it has created, done, right? Let's use this one to see what all do we have. So there's nothing inside of it. It's totally empty. If I give a name which doesn't exist, but instead of creating, I'll simply get that collection. See, it will throw error message, rag collection test does not exist. I'll clear everything. Now let's try to add some documents inside of it. These are my documents. I'll copy everything. I'll put it here. So I've divided this into five different topics. So in the first topic, I've got related to space. And in second one, the documents are related to ancient history, modern technology, food and cooking, sports. So these are all my documents. For each document, I've got a document ID. A document ID should be unique. It has to be unique at any cost. The numbering is wrong. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. Uh, and then I'm storing some metadata also, like the source. So this is where if you are building a rack with files, then you can store the page number, file name, file location, all the uh, section heading, author, all these different metadata. You can store them under the metadatas. Let's try to insert. Yeah. So everything has been added. You can see this collection has been, sorry, these documents have been added to our collection. Now let's go ahead and query. So here, if you have observed carefully, there's literally no print statements. It is taking all of the documents, it is converting them into vectors or embeddings, and then it is storing all of those embeddings in your vector database directly. I'm asking what is sushi? And this is what I got. Sushi originated in Japan as a method of preserving fish. This is one of the document that I've uploaded. And metadata. Yeah, if you see the distance here, 0.4 and 1.5. These are the different distances that it has calculated. 0.4 is extremely close, and that is why the very first one has the word sushi, and that's why it's even more closer. Let's remove everything else and let's calculate only with sushi. Now, if you see, it is 0.6. So it has increased slightly. And doc ID 14, there's 14, yeah. So topic 4, second one, topic 4, second one, there you go. This is the actual original document. Sushi originated in Japan as a method of preserving fish, and which is exactly what you got. So this is how we can use ChromaDB for creating a collection, adding stuff into that collection, and query it to retrieve some relevant results. There are also a few more things like you can take a certain document ID and then you can update the content of that document. You can also delete a certain document also, and you can also list everything. So this is how ChromaDB works. And many people don't they underestimate ChromaDB. You can use ChromaDB in your projects for production as well, not just for development or POCs, but even in production, you can use them given you are preserving your persistent client. So if this folder is gone, then all of your embeddings are gone. So let's say if you're using Azure OpenAI text embedding model for creating your embeddings, you can also pass your custom embeddings. Okay, ChromaDB is using where is it? ChromaDB is using this model to create embeddings, but you can also pass your own embeddings. How do we pass it? Embeddings equal to, and then you can pass them here like this. And you can create those embeddings using any model, whatever you want. But let's say if you're using a paid model, you have lots and lots of data. You have created a pipeline. You have written a Python code. It will create embeddings for different documents. It is saved to your collection. But now, for some reason, by mistake or by accident, this ChromaDB data folder got deleted. Now everything is gone. So, which means whatever you have paid, whatever you have done is all lost. So, this is why many people don't use it in production. But if you're careful enough, then definitely you can use it in production also. Similarly, so far we have observed ChromaDB and FastIndex. Similarly, we have Pinecone, Waviate, Milnus as some of the other vector databases which are quite popular. Pinecone is a paid one. Waviate is also a paid one. Is not a paid one. This is open source, but they are all widely used for different situations. But for beginners, I would definitely suggest either Fast or Chroma. Advantages and disadvantages. Yeah, I believe we covered most of the important stuff about what exactly is a vector database. In the next video, we are going to cover document parsing using PyPDF. See you in the next lesson. Thank you.